Okay, hello, hi. My name is Dennis Stampfer. I'm from the University of Applied Sciences in Ulm, which is just 1 hour drive from here. And I'm here to tell you about RobMoSys. It's about composable models and software for robotic systems. And it's nice to be at a ROS conference, even though the topic has not too much to do with ROS. But I will tell you why RobMoSys is interesting for you and what is in there for you, because this session now is about funding ideas and how you can get additional funding opportunities. So RobMoSys is a Horizon 2020 project, and it's running for 4 years. It's, so to say, the sister project of the ROS-I project, which is in the same call. We have 2 more years to go, and we have a budget of overall 8 million euros, where half of it is for giving away for open calls for the community in order to contribute really to the core of the project. And 2.5 million of them are still left, and we are going to distribute them next year to the robotics community by an open call that starts or that opens in February. So we have a nice video with 1 minute which tells you the basic of RobMoSys.
These are Tom, John, Sarah and Ben. They are managers in different fields. They want to improve the efficiency of their business. I would like to use robotics technology as part of my solution, like many others do in so many different fields. Standard robotic devices are not doing what I need for my applications. A custom development or adjustments would simply be too expensive. Wouldn't it be great if I could just get the robotics configuration I need for a reasonable price, because I can have it put together according to my requirements? I would like to select just that level of robotics as part of my solution that makes most sense. I don't want to be forced to live with non-fitting standard solutions. Why not make and offer robotics components in the same way as you do with PC components? RobMoSys provides the structures and the methodology to make this ecosystem, with its benefits, become reality rather than just remain a dream. We want to make robotics devices and technology composable, modular, predictable, safe, reusable and certified, guaranteeing the quality of service you require. Be part of it. Check out how you can participate on www.robmosys.eu.
Okay, so this is RobMoSys. You have seen it in the video. And RobMoSys is a project, as I said, it's running for 2 more years, but what's then after it? So it's not just a project that ends then somewhere, but it's kind of a community moderation, and it's kind of a kick-off of a whole initiative in order to really get all that vision that you have seen in the video done. So this is not going to be delivered by the end of the project but it's going to kickstart the moderation of the robotics community, so you as part of the robotics community, in order to realize all these visions there. So we coordinate the whole robotic community best effort, and we want to realize really a step change in the European ecosystem for open and industry-grade model-driven software development in robotics, for robotics. So it's about models, it's about model-driven software development, it's about systems, it's about composition, and we are the community moderators. So think of us and think of the core consortium of RobMoSys as, so get a picture of a highway. So we are building some of the highways, and there are many different islands, or let's say villages on a map in robotics, with all different technologies, different domains. And we are connecting, or we are building the highways, and we now have public funding available for the robotics community in order to make the connection from these highways to the individual villages of robotics topics, of robotics technologies, and of domains. So we really want to address, or we really want to join forces in order to address the most challenging questions and topics in robotics together. We want to be inclusive. We want to build the atmosphere of a community, actually. And we are very transparent. So RobMoSys is not just one of these projects where you wait for 4 years and then you see the results in the end in some papers or something. So I think we have so far, 1 or 2 publications actually. So we don't care about scientific publications. We really want to be transparent, and we publish our whole body of knowledge in a wiki. And that wiki is, so we have the policy of being transparent over complete. So what does that mean? We really don't wait for the stuff in order to polish, to be finished. We really want to get people to involved as early as possible in order to help us to extend that overall vision. And finally, we are contributing together with ROS into a EU digital industrial platform for robotics. And we address that from the modeling point of view. So we create the body of knowledge with meta models, supporting meta models. We provide models in order to realize that vision. We provide tooling, and we have funding to provide and to develop building blocks, and also to demonstrate our approach with pilot applications. So this is what I then will talk about with funding opportunities today. So the RobMoSys ecosystem so far is, we have the core consortium, of course, at the core. Then we have solution developers in the first open call that had been last year, and projects there are still running for 2 more months. And we have the early adopters and a second open call opening in January. The core consortium are partners, as you can see here, and this is the first wave of open calls that we had. There are 6 ITPs, we call them, 6 sub-projects if you want. And they are distributed over whole Europe, and they are focusing on, for example, quality of service. They are focusing on robotics behavior trees, safety for behavior trees, benchmarking, and also manipulation. So the roadmap, as I said, it's 2 more years running, and the first wave of the open calls, so to say, is ending in February next year. And there is a lot of contribution coming out of these ITPs. They are all going to be public then. And you are interested in the second open call probably, and there is also some opportunity for ROS in there. So I want to share some technical aspects with you. So this is an illustration that we use to communicate our user stories and our benefits. So there are many of them. I just read some of them. For example, it's about composable components, about replaceable components, reliable quality of service, reduced costs, reduction of development time, and also predictable safety. So many of these you can also achieve with any software engineering methodology. But some of them, and these which are highlighted, for example, composable components, traceable properties, and also predictable properties, you can only address them with modeling. And therefore, RobMoSys really addresses these as a main priority. And we are into the modeling aspect, so getting from the code level to the modeling level, such that you can really realize these things. So composability is one of our big keywords there, and we define composability as the ability to combine and to recombine building blocks, software components, as they are into different systems for different purposes. So you got one thing in one day and another thing, you use the same building block there the next day. So now it requires that all these properties of the subsystem, of course, they are invariant, so they remain the same. And the other way around, it's about the compositionality that requires that the behavior of a system that is composed from the single building blocks, they are predictable from the subsystems and from the building blocks itself. So meaning one building block that you use today in one system and that you use tomorrow in another system, so the building block, of course, should behave the same. And the other way around, when you build a system, you should know how the system behaves or how the system will behave because you know about the building blocks. So this is about composition and compositionality, and this is one of the core aspects of RobMoSys. So how do we achieve this? Like modeling and all these terms, it's always hard to explain. And we use an analogy. We use the analogy of a data sheet. So think of some hardware building block, and we also use the analogy of the PC domain here. So think of a graphics card, for example, here. So in the PC, you can buy this graphics card, and with that graphics card, you will get a data sheet. The data sheet tells you about, well, it tells you all the necessary facts about that component, about that building block, about that graphic cards that you need to know. All these things that you don't need to know because they are inside there. They are, of course, not part of the data sheet because they are just not important for you. So why is this important? And we think of the data sheet as the model, so to speak. So why is this important? Because only when you get the data sheet, you know how to use it. And that is particularly important when you give that component to another person, where you can't tell him, where you don't want another person to read through fonts of documentation or even look into the code itself. So using that data sheet, the other person, and the other role we call it, really can then use that building block based on the facts and based on the information that is given in the data sheet. So that enables us really to have many of these different roles there in order to exchange at a particular point in time, then their building blocks and supplying a data sheet. So these roles that then can collaborate are actually separated because they interact through the data sheet, and that is what we call, for example, separation of roles, which is also a very important aspect in RobMoSys. And with some of the roles, for example, component suppliers, you're familiar with that. System builders, you're familiar with that as well. And we are trying to, for example, introduce additional roles, such as the behavior developer, such that a behavior developer can independently of the system, independently of the components that are there, specify and develop a behavior. And a behavior that is then reusable and composable the next time, because there are certain tasks that you can still specify independently of the system or from the components that the system realizes. And this is also some outlook. There are different kinds of data sheets, of course. In RobMoSys, we focus on the technical aspects, we focus on the methodology, and there are also some semantic aspects, because when you got a bunch of code, how do you know that it is doing something about navigation? How do you know it is doing something about manipulation? This kind of additional information is something also that is related to a data sheet, and if you're interested in this, pay attention to the next talk, which is about ZeroNet. So, how about ROS? We always get the question like, what you do in RobMoSys is fine, and we want to use that for our system as well, because we're having so much time and so much pain in building systems. But we got a bunch of stuff that we already have, be it in whatever framework, for example in ROS. So we have to throw away everything and have to use RobMoSys. So this is sometimes the perception, but that is not true at all. There is no need to throw away anything. You can still just use it in parallel. You can continue using your stuff that you have, and you can then use RobMoSys for some new parts that you are developing, or even use them together. And our answer to that, technically speaking, is what we call a mixed port component. If you speak on the component level, there are also other levels, skill, behavior, task level. So on the level of the components, our answer to that is the mixed port component. And a mixed port component simply is a software component that has one leg in our world, in the RobMoSys world, and the other leg in, for example, the ROS world. But it's not only about ROS, it's also about other worlds, so to speak. It's, for example, also about YARP, another community in the robotics domain that is building frameworks component-based, and also about UPC-UA. So UPC-UA as something that is having really big impact in the future in the Industry 4.0. So do I have to throw away everything? No, you can use that together. And you can really have one component having one leg here and one leg there, or even more. So our answer to that is the mixed-board component. And if you are particularly interested in UPC-UA stuff, also look forward to the next talk, because the ZeroNet project is particularly addressing that as well. If you want to see a video of that, doing that in real time or in like live, then you find information on that in the wiki, in the RobMoSys wiki. And we are, so the ZeroNet project is also following that approach for ROS-I. And for ROS-II, we in the RobMoSys consortium are really looking for experts for ROS-II that really can help us getting ROS-II and getting RobMoSys all the gaps closed there. And really, because the effort in order to come up with such a mixed-board component always depends on the kind of then target framework of the kind of target goal. And ROS-II, for example, there is all these discussions going on, whether to switch, whether to not, how much effort, and all these kind of things. And ROS-II, there is going to be much more similarity with the RobMoSys concept there. So we are really looking forward to more people using ROS-II. And we are actually in the open call looking for ROS-II experts that really can help us to contribute there. So, about the open call, that's what you probably are interested in. So the first open call we had, I mentioned it before, we had 6 integrated technical projects. They were running for 12 months. And the focus of the whole open call was on the RobMoSys platform, on the RobMoSys methodology and structure, and basic technologies. So speaking in modeling terms, it's about the meta models, and of course about software and tooling to provide that, so to say, the highways of software. And one of the results is a workbench that you really can already use, and you can start for robotic software development, and that workbench is available for extension, for example. That's one of the results there. And now the second open call, we got 2.5 million euros in there. It's opening on February next year. It will stay open until April, and we will have a set of much broader funding instruments. So in Open Call 1, there was only one instrument, like one big project, multi-consortia project. Multi-partner consortium, yeah. In these 12 months. And now the second open call is going to be much broader there. I will tell you about that in a minute. And the second open call, that was also one of the lessons learned in the first open call. There is this coaching thing. So all the projects that have been in there in RobMoSys in the first open call, they have been assigned one coach. And that coach really helped the projects in order to align, in order to better realize the RobMoSys methodology and the RobMoSys story. And we are really looking for experts that are willing for this kind of coaching, and really in order how to contribute to the RobMoSys approach. And one of the focus in there will be, of course, pilot applications, because now we got a lot of tooling available, and now in the next step we want to show that RobMoSys can really be used, and the benefits, like generating success stories, and there is money for that. And there we offer pilots. I will tell you about that also. It's also about extending the methodology and baseline. And so if you want to speak in these terms again, it's about the models very concretely. And if you are interested in more information about that, we have a brokerage day in February next year, also in Munich. So if you have an idea for a proposal, you want to discuss that idea with us, you want to find partners to join you, join us there. We will discuss your ideas, and you have the ability to pitch your ideas as well if you are interested. Of course, all that information is like a draft, so the second open call is just being prepared, and please check the official documents in February. So one last thing for the instruments that you're probably interested in. So we have 4 instruments in order to distribute the 2.5 million euros there. We have one instrument for fast adoption, so this is probably interested to industry. if you want to make use of the RobMoSys approach, there's some money in there in order to apply it and to show that it's really like generating success stories. We have also ecosystem challenges as the second instrument here. That helps us to enrich the methodology, and there are some topics there, and I can tell you that ROS-II is going to be one of these topics. And also one instrument for expert community building, where we want to address individual experts in order experts that are experts on a particular topic that we can then have sometimes working together with us on a very particular topic, very focused. And we also have a fourth option for medialization that goes into the direction of education. You see the word academy, so it's about educating people, about really providing documentation, material, and all that for RobMoSys. We have pilots available. They are available for use. So they are provided by the RobMoSys consortium, and you can, for example, demonstrate your contributions with that. That is an offer from our side if you want to show something but you don't have big applications or robots in your own place. Thank you.
Thank you very much, Dennis. Do we have questions from the audience? Mirko, right next to you.
Maybe just a question. Do the project at the end, or is there an intention that the project at the end provide also any kind of tool that will support the process of the foreseen process?
I didn't get the last point, but the question was about whether tooling is available at the end of the project. So when that's the core, yes. It's going to be at the end of the project available, of course, but it's also available just now. If you're interested in that, so parts of this vision are already like graspable, and you are able to get parts of these visions already by tooling today. So go to that website and check about the tooling. There is going to be a major update end of the year, beginning next year, but there is information there, and there is a tooling there. It's actually a workbench for robotic software development, and that you can really use to build software components, to compose systems, to compose applications. And so the whole workflow is in there, and it's a workbench, and you can also, if you are interested, that's an option, you can extend it. But there is tooling, yes. And some of the ITPs are also providing additional tooling, for example, tooling for robotics behavior tree editing, and quality of service modeling and monitoring. So that's going to be available this year.
Dennis.
Thank you
for your presentation.
Having me here.